start the recording. Dah start ke ni? Okay. Bismillahirrahmanirrahim. Assalamualaikum and good evening. Today is 17th of June. We are going to continue with our lecture on this Boolean algebra. This is part 3 of the lecture. For part 1 and part 2, you can review on my YouTube channel. Okay, you can download, I think, the videos there. Also, you can also search in the MS Team archive, video archive. You can also find there. You can surf under my name. Okay. So now I'm going to share the slides. The slides. Hopefully you'll be able to see. Okay. Okay, I'm going to share. Share. Where? No files available. This is desktop. No, I'm not going to share the desktop. Share. Yeah. Sekejap. Apa lagu tu? Sekejap. Where? No files available.
Kita tinggal berapa lagi tajuk, sir? Kita tinggal, ni tajuk last ke, sir?
Tajuk lagi banyak lagi.
4 atau 5.
Banyak lagi.
Baik, sir.
Sekejap. Share. Okay. Do you see the slides?
Yes, sir.
What do you see?
Step 1, step 2, step 3, step 4.
Boolean expression and truth table.
Okay. Now, basically, that okay, we are going to continue from where we left off. The Boolean expression and truth tables. We have gone through the Boolean expression, which is we have gone through the SOP, which is the sum of products form, and also POS, which is product of sums form in the last lecture. And now we are going to go into how are we going to construct the truth tables based from the Boolean expression. So when you have the Boolean expression, first step is that you need to determine the domain of that expression. Basically, the domain is basically how many variables that you have, A, B, C, D, and combination of binary values as an input, 0, 0. Let's say if you have 4 inputs, let's say you have 4 domains, A, B, C, and D. So the combination of 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, and all those combinations, all possible combinations. So you prepare that. Then after that, that expression, you convert the expression into standard SOP or POS forms, either one. Whether you convert into SOP or you convert into POS. Then you find the binary values that make the SOP is equal to 1 or the POS equal to 0. Okay, like the what we saw last lecture. Then the remaining combination will be equal to 0 for SOP and equal to 1 POS. Then you fill up the truth tables. Okay. So converting first, if you want to convert the SOP expression to truth table format. Let's say you have an expression of this A bar B bar C plus A B bar C bar plus A B C. So from here, the step one is that you find the domain. What is the domain? The domain is A, B, and C. So there are 2 to the power of 3 combinations. So you have 8 combinations of binary values of the variables. So what are those 8? Basically 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, then 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay? So those are the combinations. Then the binary, you go into the second steps, which is the binary values that make the product terms equal to 1. So for this term, A bar, B bar, C, so the terms is that A0, B0, and C1, which make it 1, 1, 1. Then this will give 1. And another term is that A, B bar, C bar, A1, B0, C0. So therefore you have 1, 1, 1, 1. So you get 1. And for the term A, B, C, then all ones, we give you a 1. So only these 3 sum of products has a value of 1. The rest are 0. Then you fill up the truth tables. So this is the truth table. Basically that you construct the input. So these are the 3 domains. Step 1. Then you set all the combinations. 2 to the power of 3, 8 combination here. Then you set the output. So you fill out the ones that give you the 1. Okay. So which is 0, 0, 1 here, 1, 1, 0, 0 here, and 1, 1, 1 here. So the rest are 0. This is how you construct a truth table from the Boolean expression. Any question? Very easy, right? So now, let's say if you want to convert the POS expression to truth table format. For example, you have this POS, A plus B bar plus C, and with A plus B plus C bar, and with A bar plus B bar plus C bar. So this expression. So from here, you can see that you have 3 domains, A, B, and C. Here. And the same thing, you have 8 combinations of possible binary values. Then from there, you find the terms that make it 0. For POS, you find the value which make it 0. So for this 0, this to be 0, or this to be 0. Okay. So the first one, A plus B bar plus C bar. So this to make it 0. So A is 0. B bar is what? To be 0. So therefore B is 1 and C is 0. The second terms is A plus B plus C bar. So A is 0, B is 0. So C bar is 0. Basically that C is 1. So for the term A bar plus B bar plus C bar, so A bar to be 0 is require A to be 1. So B is 1 and C is 1. So From here, you fill out the truth tables. So the input, same. And the first term basically is this term, A plus B bar plus C bar, which is 0, 1, 0. So this is the 0, 1, 0. This term, this. Okay. The second one is 0, 0, 1. So these terms. Okay. This. Right. And the third one is 1, 1, 1, 1. Here. So this is the truth tables. So the rest, you fill out with a 1. So you see that the POS and SOP is basically is a complementary. For SOP, you find the ones. For the POS, you find the 0. Then you fill out the ones. So this is the how you construct the Boolean, the truth tables from the Boolean expression. Any question? If not, I will continue.
No, sir.
Okay. Determine the standard expression from a truth table. So list the binary value of the input variable for which the output is 1 for SOP and 0 for POS. Then convert each binary value to the corresponding product or sum terms by replacing it with the corresponding variables and variable complement. So basically that for SOP, 1 you convert into the variable. If it's 0, you convert into variable complement. For example, let's say 1 is basically A. So therefore, 0 is what? A bar. This is for SOP. For POS, the 0 you convert into variable. Let's say it's a B. Therefore, the 1 is the B
bar.
I should buy the tablet lah, senang nak conteng. Sekarang I pakai mouse je. So for example,
Beli saya boleh beli stylus ke?
Itulah. Dia punya benda tu actually RM100 kot dekat Lazada. Bulan depan dah beli. So, for example, for SOP, let's say 1010. So this is actually A, B bar, C, D bar. So this, right? So if it's POS, for example, 1001 is actually A bar plus B plus C plus D bar. Right? So for this example, from the truth table, determine the standard SOP expression and the equivalent standard POS expression. So from here, you have the input A, B, C. And for the SOP, remember, you find the which one? So these are the four SOP terms. Okay. What are the SOP terms? So basically that you have A bar, B, C plus A, B bar, C bar plus A, B, C bar plus A, B, C. That is for the SOP. Okay. Here. Yeah. And for the POS, you take the one with the 0. For the POS. Okay, you take this one. which is, remember, for POS, 0 is the variable, 1 is the complement. So A plus B plus C, so basically this, and with A plus B plus C bar, which is this, and with A plus B bar plus C, which is this one. No, this one. And the last one, A bar plus B plus C bar is this one. So that is how you write from the truth tables to the expression. Okay. Clear?
Pening sikit sir.
Clear.
Pening kat mana? Which part that you pening?
Yang
Which part?
Sir, kenapa ada nilai A kosong, ada nilai B, A bar ada 1?
That
Faham.
one is under for POS expression. Remember, go back to the previous lecture.
Oh, okay.
POS. If it's SOP, 0 is bar, 1 is no bar.
Okay. Okay,
Okay.
sir.
So,
Sir, Ayuni couldn't join the meeting, sir. Dia ada
Apa?
internet. Masalah internet, sir.
siapa?
Ayuni, sir.
Okay. Tu dia ada tu.
Tadi dia ada masalah, dia tak boleh connect.
Oh, tu living lah. Okay. Tak apa, nanti dia baca, dia tengok dekat YouTube lah.
Alright, sir.
Right. So, clear. Hafizuddin, which part that you are not clear?
yang previous slide sir.
Previous slide. Here.
Yang tu sir.
Wait.
Saya tak faham yang, saya tahu yang POS sebab kita dapat kosong. So yang bawah tu sir, saya blur
That one
sikit.
is SOP. The ones. Here. There. Here. 1. List out all the 1 for SOP. 0 for POS. Okay.
Oh.
Okay. If it's 1 in SOP is the variable, 0 is the complement. For POS, 0 is the variable, 1 is the complement. So this is in the equation. This one is the term. You select the term which equal to 1 for SOP to be included into the Boolean expression. For POS, you find the ones, the 0 to be included into the Boolean expression. For the variables, is this one, this part. Okay, here. So for the expression, to determine the expression for SOP, you select the one is with the 1. For the POS, you select the one with the 0.
Oh.
Okay.
So nanti kita nak determine dia kalau contoh yang 1 tu, 011 tu, SOP kan sir?
No.
I mean,
This one, from this truth table, you can write 2 expressions. One in the SOP forms and another in POS forms. If the question asks you to write in the SOP form, then you find the output which equal to 1. So this will be included in your SOP form of the expression. For the POS expression, from this truth table, you find the one with the output of 0. So that's why you have this. This is for SOP. This is the equation from the same truth table. For the POS, this is the equation from the same truth table. It will give you the same result, but different expressions. But in terms of the electronics, it will give you the same result, but 2 different implementation. Clear?
Oh, clear sir, clear sir.
Clear sir.
Okay.
Okay sir.
So let's review. For the standards SOP expression just now, here, if it's SOP, you select this one, the ones. So you get the A bar BC plus A B bar C bar, this, plus A B C bar plus A B C. So this, for SOP, these are the mean terms. Sum of product actually will give you the mean terms. If you want to write in the form of mean terms, so therefore F1 is equal to, this is actually M3, because M0, M1, M2, M3. So M3 plus M4 plus M6 plus M7. So it can be written as the summation of 3, 4, the terms of 3, 4, 6, and 7. So this, if you write in the mean term format. Okay. For POS, basically you take the one 0, the output as 0. Then you write the expression, which is in terms of POS, the product of sum. So the first term is that A plus B plus C. The second term is A plus B plus C bar. The third term is A plus B bar plus C. And the last one is A bar plus B plus C bar. So this is actually in the form of max term. So in terms of max term, you get this. The function, the expression F1 is equal to the max term 0, dot with max term 1, dot with max term 2, dot with max term 5. So this is actually max term 0 here. This 0, 1, 2, and 5. So it can be written as the product of max term 0, 1, 2, 5. Okay. This one you have to review back with the previous lecture. Okay. Now, we are going into a new topic, which is the Kanu map. Now, how are we going to reduce the expression further? By using the Kanu map or K map. So the Kanu map is actually provides you a systematic method for simplifying Boolean expression, and if properly used, will minimize SOP or POS expression. It is actually a graphical representation of the truth tables, because it presents all the possible values of the input variables and the resulting output of each value. So basically that Kanu map is a graphical representation of the truth tables. The same truth table you convert into a map. The K map is an array of cells in which each cells represent a binary values of the input variables. K map can be used for expression with 2, 3, 4, and 5 variables. If you add more variable, basically that one will be very complicated. So K map actually useful when you are dealing with expression up to 5 variables. So for 3 variables, you require 8 cells, because 2 to the power of 3. So you have 8 cells. For 2 variables, you have 4 cells. For 4 variables, you have how many cells? 16.
16.
For 5?
16,
20.
20,
32.
20. Yeah,
22. Kenapa 22 sir?
2 2 to the power of 5?
32 sir.
Yeah. 2 to the power of 5. Berapa?
Oh,
32.
32.
Yes. So this is a two variable K-map. It's an array of 4 cells. So you have A, it can be 0 and 1. B can be 0 and 1. So this is the K-map. So this represent A bar B bar. This represent A bar B. This represent A B bar. This represent A B. So you see this basically B is really is either 0 or 1. A is either 0 or 1. Okay. So this is the two variable K-map. So this is actually if you number using the decimal notation. This one I rarely use lah. So basically this is the one. This is a two variable K-map. How do you construct this? Basically that you put one variable here and another variable here for the two variables. So this one is basically is the horizontal. Okay. This column represent a B equal to 0. This column represent B equal to 1. This row represent A equal to 0. This row represent A equal to 1. Okay. So row and column. One variable is in row, in column. Another variable is in row. So for this box, this quadrant basically is 0, 0. So that's what A bar, B bar. For this one, A is 0. So A bar, because 0 is bar, complement for Canomat. Because Canomat, this one is using the SOP. Okay. And B is 1. For this one, A is 1. B is 0. So B bar. For this one, A is 1. B is 1. So A, B. Okay. This is the two variable K-map. This is a three variable K-map. Three variable K-map. So you have 8 cells. So you see that A is one variable. So the other one, you have B and C. Okay. And the rule of constructing the K-map is that only one variable change at a time. For this one, okay, clear. 0 change to 1. For this one, you start with 0, 0 because B and C. B 0, C 0. So to change to the next column, only one variable can change. So in this case, C is changed. So B is remain as 0. So C is changed to 1. So from here to here, only one can change. So basically that B is changed from 0 to 1 and C remains. And from here to here, only one can change, which is C is changed from
C bar.
1 to 0. And from here to here, only one can change, which is B is changed from 1 to 0. So basically that this corner actually connected to this corner. This corner is connected to this corner. Okay? Clear?
Boolean.
So this actually, a lot of students basically that confused over here is when they put BC 0, 0, 0, 1, 1, 1, 1, 0. Sometimes you want to do it fast, you put 0, 0, 0, 1, 1, 0, 0, 1, 1. So that's wrong already.
Sir,
Yes.
dekat dalam
Yes.
sorry sir, sorry. dekat dalam exam nanti kita kena construct ke kalau dia buat table
Yes.
yang ada A, B, C bar ni ke kita terus buat dalam binary?
Ini binary lah ni.
Yelah, tapi mana satu yang kena buat, yang ada A, B, yang ada variable ke kita yang terus ada binary?
Terus ada binary lah. Sekarang ni I nak explain.
Okay.
Each cell tu representing apa benda. So for example, sometimes you get careless, you put 0, 0, 0, 1, 1, 0, 1, 1. That is wrong already because this part is wrong. When you put 1, 0, basically that two variable change at the same time. From 0, 1 to 1, 0, that B has to change and C has to change. That actually violate the rules. The rule is that only one variable can change at a time.
Alright.
So that's why it's 0, 0, 0, 1, 1, 1, 1, 0. Okay? Remember that. One variable change at a time. So, for example, you have this 3-variable canoe map. For example, figure below shows a 3-variable truth tables and the corresponding K-maps. For example, you have this. This the truth tables, and you want to convert into the K-map. So this is how you do it. 0, 0, 0, which is this one, is 0. 0, 0, 1, A is 0, B is 0, can be this, and C is 1. So here, 0. The third one is 0, 1, 0. So still A is 0. Okay, A is 0. B is 1. So B is 1 and C is 0. So this is the one here. So basically this is this. This one is 0, 1, 1. Basically this. This one 1, 0, 0. So 1, 0, 0 is this. And another one 1, 1, 0. So 1, 1, 0 is actually this. Nampak? And the rest are 0.
Nampak, sir.
Okay. So,
Nampak sir.
why tak nampak?
Dia follow yang input tu 000, kita ambil lah kan dekat 000 tu, sir.
Yes. And you put the value there.
Faham, sir?
Okay.
Tapi kenapa aturan dia 0, 1, 3, 2, 4, 5, 7, 6?
So, because remember, the rule is that only one variable can change at a time.
Oh my God.
Here. Okay, B, C. 0, 0. From here, they can only change one. So 0, 1. C is changed. And from 0, 1, can only change into 1, 1. You cannot change to 0, 0 because you already have 0, 0 here. So it's 1, 1. It cannot be 1, 0. If it's 1, 0, let's say this, this is 1, 0. If you put here, so basically B is changed and C is changed. You violate the rule. So that's why 1, 1. So from 1, 1, you can only change 1 to the next one. So which one? C has to be changed because it's either 1, 1 change to 0, 1 or 1, 0. You already have 0, 1. So the one that you don't have is 1, 0. So from 1, 0, you can only change either into 1, 1 or 0, 0. So you have 1, 1 already. So basically this N is really connected to this N. It's like a cylinder. Let's say you take this, you write this on a piece of paper, then after that you fold it to be like a cylinder. So this end is meeting this end. This corner is meeting this corner is meeting this corner. So it's like a cylinder. So a map can be obtained by placing ones in the square which corresponds to the midterm of f, or by placing 0 in the squares which corresponding to the max term of f. So this one basically that we put the min term 1. So this is actually the max term 0, 0, 0, 0. Because this expression is actually represented by this equation. Is the sum of product 2, 3, 4, and 6, or the product of sum 0, 1, 5, 7. Okay? Clear? This is a 4-variable Kano map. So 4-variable basically that you have
Astaghfirullah.
the variable AB at the row and CD at the column. So you have the same thing, 0, 0, 0, 1, 1, 1, 1, 0, and 0, 0, 0, 1, 1, 1, 1, 0. So this corner actually connected to this corner. This corner connected to this corner. And also this corner connected to this corner, and connected to this corner. So it's like a sphere. So these 4 corner actually connected to each other. From here to here, only one variable move, change. From here to here is only one variable change. Clear?
Sir, the numbering, the side one, we don't use. Sir.
Which one? This one?
Yeah.
This one is just to show you which min terms or max term.
So maknanya dia akan, kat contoh dekat bahagian B tu
this-
dia satu dekat area situ je rasa.
Mana?
Yang maksud yang saya cakap sekarang.
Which one?
Apa soalan kau tu, Kish?
yang numbering.
Here.
Yeah, the one on the right side, sir.
So this one actually just to indicate to you
Okay.
which box correspond to which min term or max term.
Oh, so you refer to this box when you want to write the min term and also the max term.
I just refer to this lah.
Yeah, actually can combine also, right, sir? Like
It's just another way of showing it.
okay.
What does it mean? That's all.
Alright, okay, sir.
Okay.
Okay.
Okay. Let's say you have this expression. Okay. This is actually the SOP expression, right? Right? Sum of product, right? So this is the product. So it's sum of product. So how many terms that we have? 2, 4, 6, 7 terms. So now, the first one, A bar, B bar, C, D. So A bar, B bar is this. Okay, 0, 0, right? And CD is 1, 1. So basically this is the term. So you write 1 here for this. Yeah. Okay. The second one, A bar B. So A bar B, basically this one is 0, 1. So A bar B is 0, 1 is here. So basically that it has to be in this row. Right? Then which column? C bar, D bar. C bar, D bar, so basically 0, 0. So this one. You write 1 here. This. The next one. A, B, C bar, D. So A, B, 1, 1. So it has to be in this row. Because AB represent the row. And the column is C bar D. So basically 0, 1. So this is the one for this term. The next one, A bar, A, B, C, D. So A, B is this row, and C, D is 1, 1 is this one. So this is the one. The next one, A, B, C bar, D bar. A, B, 1, 1. C bar, D bar is 0, 0. So this is the one. You write 1 there. Now you have A bar, B bar, C bar, D. So A bar, B bar is here. C bar, D bar, C bar, B, D is here. So you write there 1. The next one, A, B bar. A, B bar is this row. And C, D bar. C is 1, D bar is 0. So this is the one. So now you have convert the SOP expression into the Kano map. So you have written it all in the Kano map. So the rest is actually 0 here. The one that is not written is actually 0. Okay. Clear? That's how you convert from the expression into the Kano map. Now you want to go into the simplification of that expression. The purpose of using the Kano map is actually to simplify the expression, so that when you implement, you can reduce the number of gates when you implement the expression into a digital circuits. So the process of simplification is as follows. The process that results in an expression containing the fewest possible terms with the fewest possible variable is called the simplification or minimization. So the rules that you need to follow are as follows. The grouping can contain only ones and not 0. So you cannot group 0 with a 1. You can only group 1 with a 1. So this is wrong. You cannot simplify this one like this, but you can simplify like this. Okay? You cannot group this because zeros cannot be grouped with a 1. You can only group 1 with a 1.
Sir,
Yes.
kalau dia group dia 0 dengan 0, maknanya?
No, when you want to simplify, you find the ones.
Oh, kalau 0 tak, kalau dia ada 0 dalam group tu, dia bukan group lah.
No, we simplify using the cell with
Ones only.
ones only.
Okay, sir.
Okay. Group may be horizontal or vertical, but not diagonal. You cannot group 1 with the 1 in a diagonal manner. You can only group is either horizontal or vertical. You know why?
Sebab dia tak ada variable yang kalau group.
Basically that for this example, this one is actually is A.
0 tak.
Is A. Because the constant is A. 1. This one is B. See? So the expression of this is actually A plus B. The
Okay.
expression for this is actually A B bar plus B A bar, because this one cannot be simplified. This one you can simplify because this one is actually A B bar plus A bar B plus AB. So this can be simplified into A plus B. So that's the usage of Carnot map. So that's why you group so that you can simplify. You can reduce the expression. So group may be horizontal or vertical, but not diagonal. This one you cannot. So it has to be as either vertical or horizontal. Group must contain 1, 2, 4, 8, or in the general 2 to the n cells. So this one is that 2 you can group. This one you cannot group. Of 3 cannot. The grouping can only be made for 1, 2, 4, 8, 8, 16, 32. In general, 2 to the power of n cells that you can group. You cannot group this. You cannot group 3. You cannot group 4. You cannot group 5, 6, 7. Cannot. 9 also cannot. 10 also cannot. So, you can only group in this number 1, 2, 4, 8 grouping. Because this one you cannot group. Because this is actually for you can only group this. Because C is constant. And this C change already. See, C change into 0. So you cannot group. So you can only group these two. Or you can group these two. But you cannot group all three when you want to do minimization. So this actually, the expression is that A bar B bar C plus A bar B C plus A bar B C bar and can be reduced either to be A bar C plus A bar B C bar or A bar B kan tak?
Tak faham je.
Tak faham? Nanti you tengoklah nanti.
Tak faham.
Nanti
Baik
you
je.
tengok nanti. So basically that
Jadi dia boleh groupkan untuk macam dekat sini A bar B bar C dengan A bar B C
so
boleh
basically
groupkan.
that here you can only group for this one you cannot group this 3 as one group, cannot. You can only group 2 and this as another one. Or you group these 2 and this standalone. And after that you write your expression lah. Okay. So but now I'm trying to tell you the rule. So you cannot do this. You can only do the grouping in terms of 1, 2, 4, 8. Okay.
Alright.
Another rules. This is also an example. You can group of 4. This is a group of 4. And this you cannot group. Even though it's group of 8, you cannot do this because you are mixing ones and zeros. You cannot do this. This is actually, if you have something like this, then basically this is group of 4 and another one is here. You can group like that, but you cannot group like this. The group must be as large as possible. So this is correct. Okay, this is correct because you have a group of 4 and group of 4 here. And this is really not simplified enough. This is wrong. This is not simplified enough. Because this one, you can have 2 expressions. 2 terms. This one, you have 3 terms. So it's wrong. So this not simplified enough. So the group must be as large as possible. So this one group and this another group. Okay. Another rule, each cell containing a 1 be in at least one group. So like this. This is 2 and this is 1. So this is actually a separate group. Group can be overlapped. So this group can be overlapped by this group. And this is wrong. Okay. Group can wrap around the tables. This is the one that I mentioned just now, which is this corner actually connected to this corner, and that corner. So here, this is actually 1. This is actually, this one actually is connected to this as one group. This as one group. So this column and this column are connected as one group. And this, okay, is actually one group with this one, group of 4. This one is group of 8. This one actually connected. So this edge is actually connected to this edge. So group of 4. So the leftmost cells in a row may be grouped with the rightmost cell. Leftmost cell, actually this is the leftmost cell. We group with the rightmost cell. And the top cell in the column, so the top cell may be grouped with the bottom cell. So this edge is actually connected to this edge. And this edge is connected to this edge. So you can do the grouping. So that is the cell adjacency. So this cell is actually adjacent to this cell, and also to this one. Adjacency is defined by a single variable change. So only single variable change from the adjacent cell. Cell that differs by only one variable are adjacent. For example, cell 0000 here is adjacent to the cell of 0001, 01, 00, this one, 00, 0010, and 1000. So this is the adjacent to this, one. So this adjacent, and this actually connected here, and this is actually connected here. See? That is the cell adjacency. When you want to do to minimize, to do the simplification, you have to remember this. Let's say if you have a 1 here and a 1 here, this actually can be grouped with this one because it is adjacent. Okay. Example. Use a Kanu map to minimize the following expression. You have A, B, C bar plus A bar, B, C bar plus A bar, B bar, C plus A bar, B bar, C bar plus A, B bar, C bar. First step, you construct the kernel map, which is a 3-variable kernel map. So A variable is on the what do you call it, horizontal, on the horizontal here, A. Then BC is on the vertical. So you correct. A is 0, 1, BC is 0, 0, 0, 1, 1, 1, 1, 0. So you draw a box. Then after that, what you do is you start to fill out the box. So A, B, C bar. So A is 1, B 1, and C is 0. So basically this is the one. This is the first term. Second term, A bar, B, C bar. So A bar is here, is this row, this row. B 1 and C is 0. So this is the one. The third one, A bar, B bar, C. So A bar, B bar, C is the one. So this is the third one. Fourth, A bar, B bar, C bar. So this is the one. And the fifth one is A, B bar, C bar. So this is the one. So now you put all ones. Next step is you start to do the grouping. So these 4, 1, 1, and 1, 1 can be grouped together. And another one is that this one and this one can be grouped together. Even though this is overlapping is allowed. You can overlap. So now all the ones have been grouped. So you cannot group anymore. So that is as far as you can go. The next step, then you write the simplified expression. So this is the group of 4. So which one is the constant? Over here, basically that you see
C.
C is 0. Okay, C doesn't change. B change, and over here A also change. So it's a C. What is C here is 0. So it's a C bar. For the second terms, for this group, which one has not changed?
A.
Basically, C is changed from 0 to 1. B does not change, so it's a 0, remains 0. So it's B bar. And A is also doesn't change, which is 0. So A bar, B bar. So this is the expression. So this expression has been reduced to that. So this is the minimization is using the K-map. That is the step that you do. You see, from the original expression, you have how many gates? 1, 2, 3, 4, 5. 6 gates. Basically that 5, 3, and input. 3 input and gates. So 5, 3 input and gates, and 5 input or gates. So you have 6 gates to implement. Whereas this one, you only need 3 gates. No, 2 gates. You need the AND gate, 2 input AND gate, and 2 input OR gate. So that is how you do the simplification using kernel map. Clear?
Yes, sir.
This one basically you need to spend time to study a bit. And I will give you the assignments maybe by tomorrow, so that you can use the assignment as your to do your practice. Okay. Another example. Use a kernel map to minimize the following expression. Now you have 2, 4, 6, 7. 7 terms and 4 variables. 4 variable is basically there are 16 cell Kano map. So you have WX as the row and YZ as the column. So you construct the Kano map. And from there, you fill up with the ones because this is sum of products. So therefore, you fill up the cell which give you a 1 for that expression. So W bar, X bar, Y bar, Z bar is this one. Here. W bar, X bar, Y bar, Z is this one. W bar, X bar, Y and Z bar is this one. And W bar X is this one, this row. Y and Z bar is this one. Okay. WX bar, so this row. Y bar, Z bar is this one. WX bar, Y bar, Z is this one. And WX bar, Y, Z bar is this one. So now you start to do the grouping. So these 4, you can group together with this, the red one, the red border. So you can group. So these 4, the corner, these 4 corner you can group. Okay, the blue one. So now you live with this one. This one you can only group with this group of 2 because you cannot group with the other. Okay. So from here, then you start to write the expression. So for this red one, basically the one that is changing, Y is changing, Z is changing. So the one that W also changed because from here to here, you have to change the W from 1 to 0 or 0 to 1. So the ones that not change is the X. So you have X bar, Y bar. So for these blue ones, okay, the ones that's not changed are the X because X remains 0 and Z also remains 0. The others are changing. So X bar, Z bar. And the next one is the green one. The green one is that, see the Y and Z does not change. So Y is Z bar and W also remain constant, which is 0. So W bar, Y, Z bar. So this is the minimized expression for this. Now, the exam most probably in something like this. Design a logic circuit that implements the truth tables. So you are given a truth table. You are given this. Now the question is that you need to implement the logic circuits which produce this output based on this input. So what you need to do is that you draw the K-map. You draw the K-map because this is 4 variables K-map. So you have A, B, C, and D. You draw this and you fill out the ones. You fill out the cell with a value of 1 from the truth tables. So 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 1. So these are the truth tables. that you have. From the next step, after that, you need to simplify the truth tables. You simplify the truth table by grouping. So this can be one group, this can be one group, this can be one group, and this can be one group. So you have how many groups? 1, 2, 3, and 4. From this grouping, then you write the simplified K-map. So you got this. So the green one is basically this. The blue one is the C bar D, because the A and B are all changed. So this is the blue one. The red one, B bar,
B bar, C bar.
C bar. The yellow ones, A and
D.
B. And the green one is A bar, B bar,
B bar,
D bar. So this is the expression, the simplified expression that you have. From this simplified expression, then you draw the logic circuits. That is the logic circuits that you need to draw. So you have A, B, C, and D. So A, so this one basically gives you A bar, B bar, D bar. This one gives you the B bar, C bar. This one gives you the C bar, D. And this gives you the A, D. And all sum up to become Y. So this is how you start from the expression, this is you start from the truth tables, and from the truth table you construct the K-map, the Kanu map, then you do the grouping, and you write the simplified expression. From that simplified expression, then you draw the logic circuits to implement that expression. And the question also can start from the equation, from the expression, which is not minimized. And from there, you can go into the Kanu map, you construct the Kanu map, then you do the grouping, then you write the simplified expression, then you draw the logic circuits. So I can make that kind of question also. Okay?
Okay, sir. Sir,
Yes.
take 5, sir.
Kejap sikit lagi. Nak habis lah. Boleh?
Boleh ke?
Nak take 5? Oh, nak selesaikan, lepas tu we can stop.
Selesaikan.
Selesaikan, sir.
Okay.
Selesaikan, sir.
Okay, now we go into don't care conditions. Like some of you lah, don't care lah. So don't care is basically that where you have the cell which is undefined. It does not matter whether it's 0 or 1. It's not defined. So sometimes a situation arises in which some input variable combination are not allowed. Since these unallowed states will never occur in an application, they can be treated as don't care terms with respect to their effect on the output. So these don't care terms, we place an X in the cell. When grouping the ones, the X can be treated as 1 to make larger grouping. The larger a group, the simpler the resulting terms will be. So you can use the term, the don't care cells to simplify your expression. Example. Let's say you have that truth tables. Okay. So 0, 1s, and the rest are don't care. X means don't care. So from here, you convert into the K-map, where all the ones you put in and the don't care also you put in the K-map. 0 you don't have to put in. So now, if we simplify without consideration of the don't care, you get this expression. Okay, you get this expression. Because you only take basically this and this without don't care. So you get this one is A, B bar, C bar, and this one is actually A bar, B, C, D. So you get this. So you have to have 3 input and 4 input and 2 input OR. If we take into the consideration of the don't care, you use it in simplifying your expression. This one actually you can group as this group and this group. You can take this is as 2, so you can simplify as A plus B, C, D. So this is actually the simplest expression that you can use. So you utilize the don't care to simplify your expression. Okay.
Sir, macam mana
Clear?
dia buat BCD tu, sir?
BCD. This one. This is BCD. So for this one, these 8 cells, you see, from here to here, A is constant, right? Oh, wait. This one is actually, this one is A. This one is A, So this big one is A. So this one, this BCD, BCD is this one, BCD. Here.
Oh, okay, sir.
Nampak? B is
Maknanya
this.
yang dekat area A, B bar, C bar tu tak payah masukkan lah, sir?
This one. Tak payah because
Sebab dia dah dengan 8.
Because you use this and this. Because you utilize the don't care to simplify your expression.
Alright, sir.
Okay. Clear? That's all.
Clear, sir.
Alhamdulillah, alhamdulillah.
Huh?
Clear.
So now I'm going to discard all my conteng-conteng tadi. If you don't have any question, okay. So now, where are we? Okay. Yes. Now I didn't share anything, So now it's about 10 o'clock. So we have completed on this Boolean algebra. The next topic will be on flip-flops. So you want to stop here or you want to continue?
Continue tomorrow.
Continue tomorrow. Okay.
Tomorrow,
So,
sir. Hujan here. Sini hujan, sir.
You are going to continue tomorrow, okay?
Berapa okey?
Alright, sir.
Yes, sir.
So, any question on what I have explained today?
No, sir.
So, hopefully that you can do your revision, try to get a further understanding. And what I will do is that I will put this video, this recording on my YouTube channel so that you can access and you can do your revision. Okay? Any question? If
No,
not, I'm
sir.
going to stop the recording.
No, sir.
No question, eh? So now I'm going to stop the recording and see you tomorrow.
At night juga ke, sir?
Okey, sir. Naik juga ke, sir?
Yes, sir.